Dopamine, the chemical of motivation, learning, and prediction. When people talk about dopamine, they usually call it the pleasure chemical. It is blamed for addiction. It is blamed for distraction. And it is often described as the reason modern life means we are constantly overstimulated. But this description is deeply misleading. Dopamine is not about pleasure itself. It is about motivation, learning, and prediction. To understand dopamine properly, we need to start with its history. Dopamine was first identified as a chemical in the brain in the late 1950s. For many years, scientists believed dopamine was just a precursor, a stepping stone used by the brain to make another neurotransmitter called norepinephrine. It was not considered important in its own right. That changed in 1957 when Swedish neuroscientist Arvid Carlsson demonstrated that dopamine was not merely a building block, but a neurotransmitter with its own critical functions. Carlsson showed that dopamine was essential for movement. When dopamine levels were depleted in animals, the animals became rigid and immobile. When dopamine was restored, movement returned. This discovery directly led to the understanding of Parkinson's disease, which involves the loss of dopamine-producing neurons. Carlsson later received the Nobel Prize for this work. As research progressed, scientists discovered that dopamine was doing much more than controlling movement. It was deeply involved in motivation, learning, and decision-making. One of the most influential discoveries came from studies of dopamine neurons in the midbrain. Researchers found that dopamine neurons did not simply respond to rewards. Instead, they responded to changes in expectation. This led to one of the most important ideas in neuroscience: reward prediction error. Reward prediction error refers to the difference between what you expect and what actually happens. Dopamine activity increases when outcomes are better than expected. It decreases when outcomes are worse than expected, and it stays relatively stable when outcomes are exactly as predicted. This means dopamine is not signaling pleasure. It is signaling learning. It tells the brain whether its predictions about the world were correct and whether future behavior should be adjusted. Here is a simple example. Imagine you receive an unexpected compliment. Dopamine activity increases because the positive outcome was not predicted. Now, imagine receiving the same compliment every single day. Over time, dopamine activity decreases because the outcome becomes predictable. The experience may still feel pleasant, but dopamine no longer responds strongly. Dopamine is sensitive to surprise, not enjoyment. This leads to a crucial distinction in neuroscience. Wanting is not the same as liking. Liking refers to the experience of pleasure. Wanting refers to motivation, craving, and pursuit. Dopamine is primarily involved in wanting. You can strongly want something, even if you do not enjoy it very much. This explains why people often chase goals, habits, or rewards that no longer make them happy. Dopamine keeps pushing behavior forward even when satisfaction fades. Dopamine plays a central role in learning. When an action leads to a better than expected outcome, dopamine strengthens the neural pathways involved in that action. When an action leads to a worse than expected outcome, dopamine weakens those pathways. Over time, this shapes behavior. This is how habits form. This is how skills improve. And this is how behaviors become repeated, sometimes automatically. Dopamine is also deeply involved in decision-making. It helps the brain evaluate effort versus reward. Tasks that seem worthwhile trigger dopamine activity. Tasks that seem unrewarding or pointless do not. This is why motivation can disappear when rewards feel uncertain or delayed. It is also why anticipation often feels more intense than the reward itself. Dopamine peaks during the chase, not the outcome. One of the most misunderstood areas involving dopamine is addiction. Addiction is often described as too much pleasure, but that is not accurate. In addiction, dopamine systems become sensitized. Cues associated with the addictive behavior trigger intense dopamine responses. At the same time, the pleasurable effects of the substance or behavior often demonstrate tolerance and decline. Craving increases. Enjoyment decreases. This is why addiction is compulsive rather than joyful. Dopamine has taught the brain that the behavior is extremely important, even when it is no longer satisfying. Dopamine is also involved in movement. In the motor system, dopamine helps initiate and regulate voluntary action. In Parkinson's disease, dopamine-producing neurons gradually die. This leads to tremor, stiffness, and difficulty initiating movement. Treatments that increase dopamine levels can improve motor function, highlighting dopamine's essential role in action. Here are 5 everyday examples of dopamine at work. First, when you feel you cannot stop checking your phone, dopamine is driving anticipation and habit, not pleasure. Second, when learning a new skill feels exciting at first and then becomes routine, dopamine activity decreases as predictions improve. Third, when a reward feels disappointing despite high expectations, dopamine drops sharply. Fourth, when a habit becomes automatic, dopamine helped train the brain long before the habit felt effortless. Fifth, when motivation disappears despite knowing something is important, dopamine signaling related to expected reward has weakened. There are several key facts about dopamine that are often misunderstood. Dopamine does not equal happiness. High dopamine can coexist with stress, anxiety, or burnout. Dopamine does not get used up or depleted by pleasure. Dopamine neurons fire in patterns related to learning and prediction, not constant reward. Blocking dopamine does not eliminate pleasure, but it does reduce motivation. Increasing dopamine does not guarantee satisfaction. So what is the big picture? Dopamine is not the pleasure chemical. It is a motivation signal. It is a learning mechanism. It is a prediction system. Dopamine tells the brain what to pursue, what to repeat, and what to avoid. It helps the brain adapt to the world by learning from surprise and expectation. If acetylcholine allows clear thinking and notice, dopamine provides the drive to act. And understanding dopamine properly helps explain habits, addiction, burnout, modern distraction, and why chasing rewards does not always lead to happiness.
If you enjoyed our channel, please click subscribe.